All right, let's try a few more chain rule problems that mix in some of our previous methods of differentiation as well. So here we have I'm going to rewrite this as the derivative with respect to x of tangent of x to the negative 2. So I did that because I'm setting myself up for power rule. So my outer function here is tangent, my inner function is x to the negative 2. So remember, we start with the derivative of our outer function. The derivative of tangent is secant squared of whatever was inside of tangent, x to the negative 2. And don't forget to chain on the end the derivative of what's inside here, negative 2x to the negative 3. So this is an unsimplified answer, but acceptable for AP. Moving on to number 4. Once again, I'm going to rewrite this in a way that makes sense to me to see a composition of functions that I know how to take the derivative of. So in this function, it might not be so easy to see what the outer and the inner functions are. To me, my outer function is this power rule, x to the 1/2, and my inner function is this stuff here, this trinomial. So now that I know my outer function and my inner function, I can do the chain rule. Well, what's the derivative of this outer power rule function? It would be 1/2 times whatever it is to the negative 1/2 power. But what was inside of that function is this trinomial. So now don't forget, I need to chain on the end the outside function, the derivative of our inside function, which using power rule, 16x for the first one, derivative of the second term, negative 16, and the derivative of my constant is 0. So once again, an unsimplified answer, but we can practice our rules. Last but not least, actually I saved the best for last because this one is a cool example. We are taking the derivative with respect to theta of cosine of 3 theta plus 1, but that's all being squared, all right? That's what cosine squared means. It means we're taking whatever cosine is and we're squaring it. So now if we look at this composition, it's 1, 2, 3 link chain, a 1, a 2, a 3 link chain. So chain rules work for beyond 2 links. It could have multiple links. It could have 15 links in the chain, but we keep on starting from the outer chain and linking our way through the derivatives of the inner functions. So in this case, my outer function is squared. So my derivative of a square would be 2 times whatever is inside of that function to the first power. Well, what's inside of that? Cosine of 3 theta plus 1. So now I need to chain on the end the derivative of what's inside here. Now, the derivative of cosine itself is negative sine of whatever is in cosine. Let me just put brackets instead of parentheses there. And now I need to chain on the end the derivative of that very inside function, which would just be 3. So this is an unsimplified answer, but acceptable for the AP. So these chain rules can happen with multiple chains of compositions of functions.